Hello, geometry students. Mr. Zacek back, and better than ever, we're in Unit 11, Lesson 6. We're continuing along with angles formed by segments. Again, you can refer back to Lesson 4 that has specific things, but I'm just going to give you kind of an overview of the four types of angles that we have. So in Lesson 5, we looked at central angles. And so central angles were equal to the intercepted arc. And then we looked at inscribed angles when the vertex is on the circle. And the inscribed angle is half of the intercepted arc. And so today we're going to add to that, we're going to add interior angles. And interior angles are half the sum of the two arcs, and then we're going to look at exterior angles. And exterior angles are half the difference of those two arcs. So those are the four types of angles, and you'll notice that three of them we're taking half. So the only time we're not taking half is when it's a central angle. Okay, so let me walk through this. We're going to look at number one. So we always want to start off by identifying where is the vertex. That vertex is on the circle, so this is an inscribed angle. Again, the inscribed angle is half of the intercepted arc. So in this case, when that is on there, and what you have going is that's a tangent line going out. That's how we define what that arc is. So x is going to be 1/2 of 200, and that would be 100. So x would be 100. Now, notice if you extend that line, you might have a linear pair. Maybe we'll see one of those later. Okay, number two, solve for x. All right, where is the vertex? The vertex is inside, so we're going to call this one an interior angle, and that is half the sum. So the question is the sum of what? The sum of the two intercepted arcs. So if you take these two lines and we extend them out to where they hit the circle, we find that, I'm trying to go along that arc, but that's sort of correcting it for me, that those are the two intercepted arcs. So again, you go to the ends and you see those two arcs. So x is 1/2 of 65 plus 141. Okay, so 65 and 141 is 206, and so therefore angle x would be 103 degrees. Now, this is vertical angles, so that would also be 103 degrees. All right, that's what we know, that's what we have here. All right, now, number three, what is the value of x in the problem at the right? So it says that arc AC is 178 degrees and arc CH is 102 degrees and x is here. Well, where is x located? That vertex, that's an exterior angle. And we know that exterior angles are half the difference. Okay, so the difference of what? Well, here's how we can look at that. We take our two segments that we have here and we see what are these two arcs. So it's this yellow arc here, and then this, we'll make it a green arc right here. So if we were to write that out in a formula, as we say that x equals 1/2 the measure of arc AC minus the measure of arc CH. So x would be 1/2 of 178 minus 102. So half of that would be 178 minus 102 would be 76. Half of 76 would be 35, and 3 would be 38 degrees. Okay, so there you have x on the outside. Okay, so now we've covered kind of, you see the interior and you see the exterior, and now we're just going to sort of work through a bunch of these. Okay, now we have what's going on here. We've got an interior angle, so different than a central angle because it's not at the center. So the interior angle is half the sum. So again, as we think about this, so here's our angle. If we extend these out, whoops, that wasn't my highlighter. If we extend these out, we see that's going to intercept this arc here and this arc. Difference this time is now we're given the angle. So the angle is 40 is going to equal 1/2 of 52 plus x, or x plus 52. I think the simplest algebraic way to do this question is to first multiply both sides by 2. That cancels out the 1/2, and we get 80 equals 52 plus x. And so when we subtract 52 from that, we have 8, and 28 would be x. Okay, so it's a little more tricky, or just a little more involved algebraically when you have to, when you're looking for the arc and you know the angle. Okay, so here we are again. What is the measure of AC, arc AC? And well, what they tell us here is that AC is 158. Well, and I think what this question is really asking is, what is the measure of arc CH? Let's do that one. Okay, the angle is 68. So when it's on the outside, it's half the difference. So we got to look at this too. So this would be the one arc, and then this would be our arc that we're looking for. And let's call that arc X for sake of our work. So the exterior angle is half the difference. So 158 minus X. So now again, algebraically, we multiply both sides by 2. So we'll get 136 equals 158 minus X. So we're going to subtract 158 from that. And that would be negative 22 equals negative X. Divide by negative 1. And so 22 would be X. So the measure of arc CH would be 22. All right, again, so when you're looking for the arc, it's a little different in this case. All right, now solve for X here. X is an arc. There's a little degree thing. It's a little tough to see. Now we're given the vertexes on the circle. Okay, so on, we want to be thinking that's inscribed. And the inscribed angle is half the arc. So what is the arc that angle intercepts? Well, that angle intercepts this arc right here. So if we're going from the angle to the arc, we're going to double it. So 2 times 147. So 2 times 147 would be 280, 294. Okay, so 294 is this arc. Now we know all the way around the circle is 360. So X plus 294 equals 360. And so that would be 66 degrees would be the remaining arc that we have up here. Okay, keeping these little things that we know in mind. All right, so let's try and roll through this now that we've done some of this. Okay, A, B, C, and C, D, E are in a ratio of 3 to 1. What is the measure of angle T? Well, when we have the ratios, we're always looking for do we know the sum? Do we know the sum of those two? Well, if we take these two arcs, what do you notice here? That's a diameter, AE, and so those two have to add together to be 180. So if we call this 3x and this 1x, we know that 3x plus 1x equals 180. So 4x equals 180. And so then 180 divided by 4 is going to be 45, I believe. So 45. So 3 times 45 would be 135. So this arc would be 135 and this arc would be 45. So therefore the measure of angle T, which is an exterior angle, which is half the difference, so that would be 135 minus 45. So the measure of angle T is 1/2 of 90, and the measure of angle T is 45. Okay, solve for x. Now, again, where's the vertex? So we got an exterior angle, half the difference. We're going to be subtracting here for this. The difference of what? The two arcs. What are the two arcs? Well, the larger arc is x, and the smaller arc is 40. So our exterior angle, 30, equals 1/2 the larger arc minus the smaller arc. Again, with our algebra, we're going to multiply by 2. So we get 60 equals x minus 40. Add the 40, 100 equals x. Okay, and it gives us a little bit of confidence because that arc is in fact bigger than the green arc, and which we're expecting that to be. Okay, solve for x and y. So y does not equal 60. That's what we know here. Well, so how are we going to get y? Well, let's figure out, or x. So 60, this is an inscribed angle, and what arc does that intercept? Well, that intercepts this arc right here. So if we do 60 times 2, we get 120. That would be this arc right here. Now, how does that help us? Well, the way that that helps us is x, angle x, intercepts that arc. Where's the vertex for angle x? It's on the circle. So x is going to be 1/2 of 120, which would be 60 degrees. So this is angle x, 60. Okay, now there's a few different ways to go about finding y. One of the ways that we can find y is we look at y, and here's what I want you to see. Y is an inscribed angle that intercepts this arc. Well, that arc is formed by that inscribed angle, 40. So if we double 40, 40 times 2, we get 80. So this yellow arc here is 80 degrees, and now y is going to be 1/2 of 80, which is 40. So there actually is a theorem that says if two inscribed angles intercept the same arc, then they're equal to each other. So we really could have just gone right to y equals 40 if we saw that they both intercepted the same arc. Okay? Now, here we go. Number 10. So CAH is 210. That's this big one here. CH, that's what we're trying to find. Let's call this, I don't know, let's call it A. I'm going to call it A just for the sake of it. Okay, so the exterior angle, that's what I want to notice. Exterior angle, this is 62 degrees. So the exterior angle equals half the difference. So 210 minus A. Again, algebraically, multiply both sides by 2. So you get 124 equals 210 minus A. We're going to subtract 210 from that. So 6, 76, 86 equals negative A, or negative 86. I'm going to divide by -1. 86 equals A, which is representative of the measure of arc CH equals 86. Okay, so hopefully we're building some comfort level in that type of question. All right, let's see, what do I got left? I got a bunch left. All right, I'm probably not going to do all of them, but I want to work us through definitely some more of these just to help give us some more practice. All right, so what are we looking for here? What's the question asking? Find the measure of the arc or angle indicated. So the question mark is what we're looking for. So I see that this angle intercepts this arc. Now it's on the circle, so here's how I'm going to go about that. 31 times 2, times 2 equals 62. That's this arc. Okay, so the measure of arc EF plus 62 has to equal 180. So the measure of arc EF would be 180 minus 62 would be 118 degrees. So that arc that we're looking for is 118. How did I know that? I had a diameter and a semicircle. Okay, so here we are again, and we're trying to find, in number 2, we're trying to find this arc. What do I have here? I have an inscribed angle, and that inscribed angle intercepts arc NT, or NX. So the measure of arc NX is going to equal 2 times 57. So the measure of arc NX is going to be 2 times 57 is 114. So now, what we're looking for, the measure of arc ZN plus 114 here again has to equal 180. So the measure of arc ZN, 6 and 66 degrees. All right, there we have it there. Okay, number 3, what do we have here? Vertex is on the circle. Okay, so the measure of angle F is going to be 1/2 of 108, inscribed angle, which would be 54 degrees. Here, we just work it around. The measure of arc EF is going to equal 2 times the measure of angle D. So the measure of arc EF equals 2 times 70. The measure of arc EF would equal 140 degrees. All right, just flipping them around. Now, what do we have here? Well, we've got now a exterior angle. Okay, so we got an exterior angle, half the difference. It really does help if you have a highlighter or a couple highlighters with this to kind of, just highlight those different arcs and make your life a little bit easier in doing this. So we've got our exterior angle, 40 is going to equal 1/2 of the measure of arc EH minus 105. So again, you multiply both sides by 2. 80 equals the measure of EH minus 105. Add 105 to the other side. 185 would equal the measure of EH. So in number 6, again, this is what we're given, 128. We need to remember that all the way around the circle is 360. So if we subtract this, we're going to get 232 would be our angle here, or arc there. So the measure of angle F would be 1/2 the difference, 232 minus 128. So the measure of angle F would be whatever that comes out to be. Let me see. 232 minus 128. And 104 divided by 2 is 52. Okay, so this would be 52 degrees. I think you can know how to do 7 and 8. We've done enough examples of those. Let me see if there's any other ones that I really want to make sure that we do. I want to make sure I do a couple more interior ones. So I'm going to do 11. Again, here's our interior angle. And so the measure of angle KJL equals 1/2. Now, what do? Take your 2 lines and, draw a highlighter and get those are your 2 arcs, this arc and that arc. So it's half the sum. So 170 plus 62. So the measure of angle KJL is 1/2 of 232. So the measure of angle KJL, 1/2 of 232 would be 116. Okay. Now, difference here in number 12 is that in number 12 we know the angle instead of the arc, but it's going to intercept this arc and this arc. So 110 is going to be 1/2 of 165 plus the measure of arc WK. And so again, the way to do it algebraically, multiply both sides by 2. So you get 220 equals 165 plus the measure of arc WK. We subtract 165 from 220, and when we subtract that, we get 55 equals the measure of arc WK. So 55 degrees up there. And got some other ones, but I think we've covered enough here for you, given you enough examples for you to see how to do those. All right, just want to bring you back real quick to the beginning. This is what we want to kind of like understand and study. There's our summarizer for this lesson for your outline. You might want to draw a picture with it to help you. All righty, good work. We'll see you back here soon.